Welcome to this video on steganography, the art of invisible warfare. We will analyze the theory, methods, and strategic imperatives in modern information counteraction. Let's distinguish cryptography from steganography. Cryptography hides the content of a message, making its existence obvious, like a locked safe. Steganography, on the other hand, hides the very fact of the message's existence, making it statistically indistinguishable from surrounding noise, like a grain of sand on a vast beach. The conflict is between the steganographer, the attacker, and the steg-analyst, the defender. The attacker aims to embed the maximum data with minimal statistical changes. The defender's goal is to reliably detect the presence of hidden data, even without knowing the algorithm or key. Basic steganography tactics include LSB replacement, which is simple but creates statistical anomalies. A more sophisticated method is LSB matching, or plus or minus one embedding, which better preserves the histogram shape, making detection much harder. Advanced maneuvers include hiding data in the frequency domain, particularly in JPEG files. This involves modifying mid to high frequency discrete cosine transform coefficients, which are less noticeable to the human visual system. Key algorithms like F5 and outguess are used here. The modern doctrine emphasizes adaptive embedding with distortion minimization. Changes are concentrated in busy or highly textured areas of the image, where they are statistically cheaper and less detectable. Leading algorithms include WOW and S-Uniword. The analyst's counterattack involves statistical attacks on the spatial domain. The chi-square and RS analysis attacks reveal subtle statistical traces left by visually imperceptible changes. Steganalysis is non-visual. It's about detecting deviations from the expected statistical model of a natural image. The paradigm shifted with rich models by Jessica Friedrich. Instead of searching for a single artifact, analysts calculate thousands of statistical features describing the interdependencies between neighboring pixels and feed them into a machine learning classifier for detection. The latest weapon is convolutional neural networks, or CNNs, for steganalysis. CNNs automate feature extraction, eliminating the need for manually crafting rich models. End-to-end training often surpasses traditional methods in accuracy. Andrew Kerr's square root law defines theoretical limits. The secure capacity of any imperfect stegosystem increases proportionally to the square root of the container size, $n$. This places strict constraints on covert communication, especially for large volumes of data. This is a brief blank scene. Threats to stegosystems are classified into passive, active, and malicious attacks. Passive attacks involve simple detection and extraction. Active attacks seek to damage or destroy communication. Malicious attacks involve replacement or forgery of the hidden message. This is a brief blank scene. This is a brief blank scene. The invisible war continues, escalating to the AI level. The arms race between steganography and steganalysis is dynamic. Theory sets limits, proving naive approaches are detectable. Steganography is now a vital component of modern hybrid warfare and national security strategy.